Perfect. The webinar has started. So, hello everyone. Thank you so much for joining us today for this webinar on structural health monitoring in critical areas. My name is Umbra and I work in the marketing department of Solutions. Move Solutions is an Italian company that designs and manufactures wireless structural health monitoring systems based on Internet of Things technology and with clients and partners worldwide. With me here today, we have Mark Flo, Sales Manager at Move Solutions, who will give you a brief overview of our structural health monitoring system for those between you that don't know it yet. And then we will leave the floor to Emmanuel Durand, Civil Engineer at Aman Engineering. Just a few words about Aman Engineering. Aman Engineering is a structural integrity consultancy company based in Geneva that provides professional inspections all over the world to help ensure safety and I'm quite excited to have Emmanuel here with us today. Thank you so much for joining us. Emmanuel has a long-term and diverse experience in construction. He has worked in complex projects in many different countries. And I would say that apart from your expertise, the reason why I admire your work is the passion you put into your projects. A passion that has led him to go on multiple missions, and as a volunteer to different countries to support local communities that don't have the resources to efficiently evaluate the safety of certain critical structures. Emmanuel has worked with governments and organizations to monitor the health of structures in Lebanon, in Ukraine, and most recently in Turkey. And both in Lebanon and in Turkey, he used Move Solution sensors. That's why we are here today. So today, he will go through the monitoring of Beirut silos, and in particular, why they needed to be monitored, how he decided to meet those needs, so what instrumentation he used, and what results he managed to achieve. However, before going into the details of the project, we will leave the floor to Mark, who will give you a brief overview of Move Solution system so that you can better understand how it was used during the project in Lebanon. Mark, to you.
Thank you, Umbra. Thank you so much. And thank you also, Emmanuel. Let me share and we can then continue. Okay. Okay, it's correct? Yeah.
Yes, that's fine.
Okay. Good. So as you mentioned, Umbra, so I'm a sales manager for Move Solution. I want to do a brief introduction of the company and what we do. So as you mentioned before, Move Solution is an Italian company that designed a wireless system for smart structural health monitoring. And we provide the most innovative IoT solution for both static and dynamic applications on civil infrastructure works and needs, like construction, general construction, bridge solutions, and railway or infrastructure monitoring. We provide the hardware and the software. So we provide a different sort of wireless systems, wireless sensors, and we called that we have a plug-and-play system for the low-cost installation, and also with a low maintenance cost, as our battery lasts from 2 to 8 years. About data analysis, as we will see later with Emmanuel case study, so we work in a very user-friendly platform with useful tools, function, and graphs that really support in a very easy way all the data that we need to study in a real time, real monitoring, and also at the same time is offering a real-time alerts. As a system architecture, let's see over this graph, this picture, where we can see perfectly how our system works. So we have our sensors at the beginning installation. We work under the LoRaWAN protocol technology that connecting to the gateway, and then through the gateway we send all the data to our servers where we use our own logarithm, and we proceed with the data, and then we show, as I mentioned before, all the data analysis on our own cloud platform. We also can export the data from our servers with a different kind of connectors for a specific integration in different platforms. So from my side, we can go now through the case study of Emmanuel. So thank you, Emmanuel, again. Please.
Thank you, Mark. Very good presentation. Yes, I'm very pleased of the invitation by Move Solution and all the support. So today we'll talk about Beirut. So let me now share my screen. Here you can see this is a 3D model of the port silos and the explosion site. Just to give a bit of a background. On the left here, this water we call the crater is the site where the explosion actually occurred. So it was ammonium nitrate explosion, and then of course it affected the town, and for what is the topic of discussion today, it affected the silos. Actually, the silos have been like a shield protecting part of the city from the explosion. But as you can see, and you know, because everybody has seen the images of this terrible explosion, yeah, the damage was really incredible. So when I first went to Beirut, it was not directly for the silos. I was working in town with a group of students providing support to the authorities. But then quickly, because this is my field and experience, I was in contact with the Lebanese army, and I offered them to support specifically at the silo site and to support with laser scanning, which you can see here. So it's a more precise technique of visualizing a particular scene. So I'm using this laser scanner device or 3D imager. I position all around the silo site and then combine together. And when I did that, okay, I cannot enter into too much detail here, but what I found out immediately was that the silos not only were damaged, but also they got a heat from the explosion, and they were actually with some inclination, which we can see here, but I would need another webinar to explain. But basically, the silos that we can see here in the plan view were like, if you have a body or soldier, I used to compare with soldiers. We had 3 lines of silos, and the first line was totally destroyed by the explosion. It's this line here. And the second line is the most visibly damaged. So all this is moving. That's what I found at that time, just 3 weeks after the explosion. So from that point, as a structural, as a civil engineer, I knew that it was important to follow that inclination. So I came back in Beirut multiple times, and I was elaborating reports for the group I was working at that moment. So with the Lebanese government, and issuing reports such as this one. Here again, I will not enter into too much detail. It's a technical report, which I'm happy to share. Actually, it's public. But basically, what you can see in this first graphic image, which is based on laser scan, this is showing the movement. And basically, at that time, I was showing that the Beirut port silos, which were built in two separate phases, just like two buildings, I could see very clearly that one part of the silos was not moving, I mean, over time. And the other one, which is here on the left, was moving, and moving fast. I mean, fast on the structural point of view, like a few millimeter inclination every day. From that point, and because I was not able to come, of course, every week to Lebanon, or not able to stay a longer time. I mean, my presence as a volunteer is always limited. I do the best I can, but I also have my family and my work. So I was keeping traveling to Beirut, but I was always also looking at a system that could be like a permanent monitoring, more precise, and all the time, day and night. And I knew from the school time, and because that's my field of expertise, I knew about inclinometers, but I never use in my professional work. And I quickly get in touch with Move Solution through their partner Smartech in Switzerland. And we got quickly on agreement on 4 devices. You can see here the device. And then I installed. So here I just go through the report, and you can see these are graphic documents from my laser scanning, top view. Again, this is the view from the top. I made this one just right after the explosion. Different graphic documents. Here, this is the section of the building, and I explain in this report why the silos are tilting. And then we come specifically to the cloud platform. What is very interesting and very important very important to understand is that the sensor, in this case here, the triaxial tiltmeter from Move Solution, is a totally autonomous device. It doesn't need any cabling, doesn't need any external source of power. I will show after on some pictures. Basically, you just need to fix the device with some special screws to the structure, and then that's it. The device will emit a signal of inclination with a precision of almost 1 millionth part of angular degree, which is just an incredible precision. And it will do that every 2 minutes, 5 minutes, 10 minutes. That's up to me. I select later on the platform. And it can go like this on its internal lithium battery. It can go, depending on the frequency, but between 2 years and more than 8 years, which is just much more than what is needed in that case. So it's no cable, no power, just alone. The other incredible thing, and Mark told a bit about that, it's the LoRa system and the LoRa frequency. So the LoRa frequency works on 858 megahertz. The interest of this frequency is that it goes through structures, through walls and building. It goes very far, and it consumes very little power. That's why it's called LoRa. It's long range low power. In this case, it was really the tool of choice. And actually, it is still working in Beirut because it goes so for a long time, and it's really crossing any building. In that case, we have it's sending the signal to a router we have in town in Beirut, and the router is about 1.2 kilometers away, and we have no disruption of signal. So it really works very well. And then the router, which is in town, this one needs some power supply, or it can be powered also with a solar panel in some cases. And it has a SIM card inside. And so the router will receive signal from any kilometer and send it to Italy. So why that? When it sends to Italy, then we can get any signal directly on the platform, on the Move platform, which I will show now. So in this screen, you can see, actually we are live on the screen now. And we have in this page, we have all the different actors. So this is the owner of silos, the Ministry of Finance, Beirut Port Silos, the state, and these are army components, the Lebanese army and the general security. They have been providing us with a lot of support for the installation. And then all the different actors from Amman, and local and foreign universities, and of course, Move. So here we have our different sensors. So I installed 4 in Beirut. We have them here. And to get the signal, we just click on every signal. What's important here is we can see, for example, on this one, the sensor was really key in identifying the problem in the silos and the acceleration of the tilt, which is exactly what I was suspecting. So I decided to install the inclinometer because my laser scan different measurement was showing an increase in the tilt. I said that before. And when you have a tilt, you always try to find out whether this tilt is kind of stopping, or on the other way, if it's accelerating. And as civil engineers, we worry about an accelerating movement, which generally precedes a collapse. And that's actually what happened in Beirut. We can see on this sensor here in July, okay, it's very small, but we can see here the angle. So we have 3 graphics. The first is inclination, let's say like this. The second graph is the inclination like that in the other axis. And then we have the third graph, which is temperature. So temperature of the structure in contact with the inclinometer. So in Beirut, we have 4 sensors, and every one of them is a story in itself. If I go quickly, this one here is on the crater side of the silos. And we can see here it was getting up and up the signal until some point when the silo reached here 4.5 degrees, which was already very, very big. It's already more than the Pisa Tower. But what's interesting here is we had the temperature, and we can see it reached 120 degrees because actually this sensor unfortunately burned because there was a fire at that time. So this sensor died, but it did the job until it died. And then we have this sensor, extremely interesting also. I'm just loading now. You can see the loading is quite fast. Here, this is the angle. We can see in July last year, we had like 0.02 degrees, 0.02, very small, but still going up. And then at some point, the inclination start going to 1 degree, 2 degrees, 3, 4, really fast. So it's actually, and we can see an exponential curve on both angle, either on this side or this side. So the first, you can see the first curve here or the second curve here, especially in the last moments, that's the last night. You can see here this 0, 0, it's midnight. And between midnight and here it's 6 o'clock, it went 10 degree to 15 degree. I mean, then you, of course, you know it's finished and you know it's going to go. Actually, I will not show here, but you can see on the internet, just type on the Google Beirut silo collapse, and then videos. You have so many videos with the live collapse of the silos. And what is very important to say at this point of the discussion is, I mean, why we are doing all that and what's the benefit? In this case, in Beirut, the benefit of all this structural health monitoring, first with the laser scan, but then with this day-to-day, minute-per-minute monitoring with this move solution tiltmeter, is that I was able to tell the authorities with certainty, 100%, this is going to collapse. So please remove any people in the vicinity. So when the silos collapsed, and actually we had 3 successive collapses on 31 July, on 4th of August, and on 24th of August. And every time I was able to warn the authorities and they were able to secure and to evacuate the area. So the silos collapsed, but no one was killed and no one was injured. Yeah? That's really the benefit. So it's really a life saving tool. Then on the technical, scientific point of view, there are many other benefits, of course, but it's really the key. And just like recently, I installed again, we will do another webinar, I guess, for that. I installed a tiltmeter in Turkey on hospitals, and here also it's a life-saving thing. I will just finish by showing some pictures from the installation, which is also something I can share at a later stage. Let's see here, just a second. I guess it's okay. So this is the device here, and I need to move my window. Okay. This is the tiltmeter. This is me first in the scanner, and of course you can see the condition of the silos. This is from inside the silos situation. So I was able to get the support from a speleologist of Beirut to help me install together with the firemen of Beirut port. And they bring the truck as we need to install the system at height. So we use also that big fireman ladder, works for me. So here we install on the wall of the site, only to install directly on the very top, dangerous. We install about half, which is enough because again, we are measuring angle. So more pictures here. So you see, it's a very complex situation, especially here on this side. We were directly under rubble, and actually some small material were falling because the silos are moving. So everything was done under control, because I know from the experience and observation when we can go or not go. So we went quickly, but the good thing is the system is really easy to install. It takes about 5 minutes. So we went quickly with lots of control installing, and then we go away. This is at the end of this installation and the support with the firemen. So that's what I can say about the system. It's really a life-saving device. It worked incredibly well, easy to install, and yeah, I'm really thankful to Move Solution and all the partners, everyone involved, the Beirut firemen and my friends there. So we were able to make it and save lives. Yeah, I'm sure. Thank you, Umbra. Back to you.
Thank you so much, Emmanuel. I honestly always love listening to your projects because you often really use your expertise and your knowledge to really help communities. And by choosing Move Solution sensors, you give us the opportunity to take part of beautiful projects, really. So thank you for what you do. Thank you, Mark, as well, for joining us today.
Of course.
So just a couple of words, just to say that today we saw a project that used static monitoring sensors, but Move Solutions also has a wide range of sensors that are also for dynamic structural health monitoring and environmental monitoring. So if you are interested in learning more about the sensors and our solutions, you can check Move Solutions website at www.movesolutions.it or send us an email at info@movesolutions.it. Just to let you know, the recording of this webinar will remain available and freely accessible in the section blogging news of our website and on Move Solutions YouTube channel. We love to organize monthly webinars, so if you want to stay updated, you can subscribe to our newsletter through our website. So thank you so much, Mark and Emmanuel, again for joining us today, and for everyone who followed this webinar, and see you at the next one.
Thank you, Umbra. Thank you, Emmanuel.
Thank you.